Normally, like the last questions in like a section, right? They are usually maybe thought of like the hard ones, but then not necessarily. They're, in my opinion, I'd almost like to start thinking that they're usually like the easier ones, but they usually just count the most marks. But this is just still the same. So any question that starts with hence, I mean, I think you've heard this very often already, but any question that starts with hence, you literally definitely need to use the previous question. But the funny thing is, with any exam question, any question could easily start with hence, because most of them you just need to use the previous question. But then this one, even if they didn't say hence, I mean, we already saw that there are many things we used, or rather one thing, but it was quite significant. I wanted to calculate the length of GH here. Now, the fortunate thing is, this is just like how they ended up asking us for the length of GE after we'd proven similarity. So with this question 9, it's almost like a repetition of the same thing, proving similarity, using it afterwards. And that's exactly what we're gonna do here. Before we even check on the sketch where GH is, we may even just start here and write out our expressions, right? So from these two being similar, right, automatically we already know that we are able to write out the following expressions. So let me just put this here. So with what we have here already, without even thinking about it too hard, we can already write that DE, let's see, DE over FG, DE over FG is equal to EH over GH, EH over GH, which is also equal to DH over FH, GH over FH, like that. The reason here is just the proportionality theorem. That's the reason. Oops, theorem. Prop theorem. Now, all this being said, right? Back to what we did in the previous question. They want us to get GH. So amongst all this, we can look out for where GH is. GH in this case is in one slot. So there's GH over there. Fine. So we already need to keep in mind that, okay, fine, whether we like it or not, we may have to use this ratio. Let's just maybe check if we have EH. Let's see here. EH, there's E and H there. We don't have EH at all. So, okay, fine, that's missing. Let's see what else we can use here. Amongst these and these, let's look at what we may have. So do we have DE? Let's see. Do we have DE? Yes, DE is something we have. So we might as well check that. FG, do we have FG? FG, yes, we definitely have FG. So we might as well just use these two. But then let's maybe look here. DH, do we have DH? DH, nope. So we might as well even forget about it. FH, FH, nope. So you can see it makes no sense for us to take this and this, whereas we can take these two and start somewhere. Even though we're looking for H for GH and we don't have the EH, it's better for us to take these two because here we have everything. So DE is the 45 over there. FG is the 80. And then here we have something missing, something missing. So for 3 marks, we can see, okay, fine. It's not just like you write something and you have your answer. You have like a detour here. We have something missing here. We have something missing. But our main focus is like GH. So we might as well see what we can do to maybe find EH before we carry on. But so here, let's see where EH is. So what we're gonna need to do here is we have to be a bit strategic also. So whatever you worked out in like the previous question, don't neglect it. Like here, how we worked out GH. No. How we worked out EG. Let's see where GE or EG is. It's this whole line here, right? The whole line EG here, we worked it out to be a 60. Let's see. We worked it out to be a 60. That was what? That was for, where is it?
Yeah, it's 60. It's up there.
Oh yeah, up here. So there's the 60 here. So we got EG to be 60. The unfortunate thing is EG is spread across what do you call, like both of our two triangles. There's like a portion here which is like GE, and then there's a portion here which is like HE. So obviously, whether we like it or not, that is something significant. You know, we cannot take it for granted. So I think this is where a bit of creativity may come into play. Now, this is what I mean. If you look nicely, right, with our two triangles, you have this blue triangle down here, and you have this purple triangle, the pink triangle up here. Now, the one thing you never want to forget is that with triangles that are similar, we have already shown here that triangles that are similar, their lines divide each other proportionally. And here we're speaking of DE and FG. If you look nicely where DE and FG is, DE and FG, they are at specific sides of your two triangles, sides that are somewhat corresponding to each other. Now, the best way to make sense of what I'm trying to say now is if I draw these two triangles individually. So if you look nicely, right, we have GH, and F here. If you look at the pink triangle, the way G, H, and F is aligned, for the triangle up here, we may have to consider no, H, G, and E, F. I'm talking about H, G, F. H goes with H for the triangle at the top. The G goes with the E, so we can put an E somewhere there. And then the F goes with a D, so we can put like a D over here. Let me just draw this triangle like this, the triangle at the top. So if you focus on this triangle here, right, HED, and this blue triangle HGF. So we have already seen, if we color code it, right, we can see that this H goes with this H, which is that one. And then the green, which is the E, we know it goes with the G. So the G here, we know it goes with this E. And then we can see that the F here goes with the D up there. So let's just label our purple here. So the reason I drew this black triangle down here is because I just want you to see these two triangles in such a way that is like aligned, you know. The EH here, you can see it's going with the HG there. The HD is going with this HF there. And then the GF down here is going with this ED here. Do you see that? Yeah. Okay, so without maybe overcomplicating anything, right? The one thing I'm trying to emphasize is that you see here we have ED and GF, which is let me see here. Hold on. I'm trying to see here. I think what did I write? ED and GF. Yeah. So you see here we have ED and GF, which is the same ED and GF that we have here. Now, the one thing I'm trying to bring to our attention is that with ED and GF, right? ED and GF, these are like specific lines in our two triangles that are like corresponding. Now, these two lines, they are easily giving us the ratio between our two sides. The ratio we are seeing here is 45 to 80, right? As we have written out here, ED and GF or FG, the ratio is 45 to 80. Now, the 45 to 80 in its simplest form, let's just see that in our calculator. 45 to 80. In its simplest form, it's like 9/16. But this 9/16, it doesn't matter for now. It doesn't matter for now, but it's important. Let's just leave it like that. So where I'm trying to go with this ratio is I'm trying to give us the idea that whatever the lengths we have for the one triangle and whatever the lengths we have for the other triangle, this on its own is telling us the ratio between those two triangles. Now, the way this all links up with this 60 here, if you look at the distance between GE, if you look at it nicely, GE takes into account the line GH and the line HE. Now, if you look at it nicely, the line GH and the line HE, if you look at it in terms of like these two triangles separately, these two go together. Where there is GH for the one triangle, you have HE for the other one. You can even see it how the color code, how the colors are. There's green and orange. Here there's also green and orange. Do you see that?
Yeah.
So automatically, since the ratio between this 45 and this 80 is just 9/16, it means that for any other pair of sides that like go together, the ratio is also going to be 9/16, meaning the ratio between the HE here and the GH here is also going to be 9/16, meaning the one with the smaller size and the one with the bigger size, they are going to be having a ratio of 9/16, all the sides, even if we don't know them. Though us just knowing the ratio between one set of sides automatically gives us the ratio for all the other sides. So the reason I'm saying what I'm saying now is because of the 60 that was given here. You see, this 60 here is telling us that the whole line here is 60. However, what we know is the ratio between these two lines is 9 to 16. So what we're going to do is, let me write it out nicely here. So we have the line EG. There's G here, there's E here, right? And then in the middle, or not in the middle, rather, somewhere along the lines, we have an H here. There we go. So what we know about this line EG is that this is one line from the one triangle. This is one line from the other triangle. Regardless of how long this line is, we know that the ratio between a line from the one triangle and a line from the other triangle, as long as they are like corresponding with each other, the ratio there is 9 to 16. The smaller one has a 9, the bigger one has a 16. So our job now is to share this length of 60 using the ratio 9 to 16, because the ratio is 9 to 16, but the full thing is 60. So we can share 60 using the ratio 9 to 16, meaning we'll then get the actual length of GH and the actual length of HE. Does that make sense?
Yes, yes.
Perfect. And the reason why we are saying this is because they are 100% aligned. There's green and orange, also green and orange. So let's just share this 60 using the ratio 9 to 16. So let me even write it out. We're going to share 60 using the ratio 9 to 16. Now to do that, it's just basic math, right? Where if you're going to share a number using a ratio, what you do first is you add up those two numbers. 9 plus 16, let's see what it gives you. 9 plus 16, 25, right? Okay, fine, you're getting a 25. Now what you do is you're going to take 9 over 25, you times it by 60. And then you do the same for the 16. 16 over 25, you times it by 60. You're going to get another answer. So your two answers here, we know that they should add up to 60, and they will. You see, so in our calculator, let's see here, 9 over 25 times 60. 9 over 25 times 60. This is giving us 21.6. So let's write here 21.6, right? 21.6. In the other one, let's see here, 16 over 25 times 60. 16 over 25 times 60. We're getting there 38 over 4. So let's write it out here. 38 over 4. If you look nicely, they do add up to 60. And we are seeing that, okay, these, they are definitely divided in the ratio 9 to 16. So this entire length, that's 60, right? This portion here is just 21.6. And then this other part here is just 38.4. So with all that information, it's clearly just making our life easier here, because you can see here our job was to get GH, but then we were missing this EH. So when we were missing this EH, we had to then go and hunt for it. And the issue is any question that starts with hence, it means we have to follow up. We have to look at the previous questions. The previous question, we have proven similarity. However, before that, we have gotten this as 60. And this 60 is the one thing that's literally helping us here. This is where ratio and proportion comes into play, because this is where you need to figure out that, okay, not figure out, this is where you need to remember that with the ratios, you don't want to just think of it as something that they'll always ask for directly. It's just something you will need to know to use. So here with EH being 21.6, we can just put all that into our equation, either here or either here. It really doesn't matter. Anywhere will work really. So let's maybe take this whole thing up here. If you had used the ratio 45 to 80 here, it doesn't matter. You are still going to get the same answers. So here, let me just take this because it's already, you know, simplified a bit and all that. So from here, we can just carry on and put our 21.6 where EH is. So here, let's see, 9 over 16, 21.6, and there's like GH over here. And then here, cross multiplying, you're going to have your 9 times GH. You're going to have your 9 times GH. 16 and 21.6 0.6, let's see, 16, and then 21.6. That's like 345.6.
Yeah.
345.6, and then divide both sides by the 9. That's what we have here. Pardon?
38.4.
38.4. Okay, so we're getting here 38.4. And that's the length of what you call GH over there. So in as much as it doesn't look like the most appealing answer, everything we did, you know, we didn't break any laws, if you think of it nicely. So that's going to be an answer for GH over there. Excuse me.